Hey Math 10Cs. Today we're going to look at some problem solving involving trig. Alright, so illustrations in this lesson are not to scale, so we're only going to use those to help us figure out what this thing's looking like. Example 1. Carmen's a surveyor is using a transit to determine the height of a tree. The transit is placed 52 meters from the base of the tree as shown. The angle of the top of the tree is measured to be 12 degrees. The transit stands 1.8 meters high. Calculate the height of the tree to the nearest tenth of a meter. So we are looking for this whole height of the tree. All right. However, our right angle triangle does not take into account that whole height of the tree. All right. So we're going to maybe label this distance x right there. So from 12 degrees, I'm looking for x. I know the adjacent side is 52. The trig ratio that uses opposite and adjacent is the tangent ratio. So tangent of 12 degrees is x over 52. We now go ahead and solve for x, use our calculators. So 52 times the tangent of 12 will give us x. X turns out to equal 11.1 meters, around the nearest tenth. We're also told that the transit stands 1. So 1.8 plus 11.1, that is 12.9 meters. So answer the question. The tree is 12.9 meters tall. Great. Part B asks us to determine the angle the base of the transit makes with the top of the tree. So here's the base of our transit, the angle that makes with the top of the tree. So we now have a different right angle triangle, right? We're looking for angle theta. That's going to use the height of the tree as the opposite side and 52 meters as the adjacent side. So again, the trig ratio that uses opposite and adjacent is tangent. So tangent of angle theta is the height of the tree. We just found that to be 12.9 meters divided by the adjacent side, which is 52 meters. So you go on your calculator, second function tangent, 12.9 divided by 52, come with an angle of 14 degrees. So from the base, the transit to the top of the tree is 14 degrees. Example 2. A circle with center C and radius 20 millimeters is tangent to the arms of angle POQ. All right. So if angle POQ is 50 degrees, this angle is 50 degrees. Right here, 50-degree angle. Determine the length of OC. So from O to the center of the circle, find that length. All right. What we do know about circles and tangents is this. The radius of a circle meets the tangent to that circle at 90 degrees. So that means I can draw a right angle triangle. From the center of the circle, the radius to the point of tangency of that tangent is 90 degrees. So I've got a right angle triangle there. We're told the radius is 20 millimeters. And we're asked to find the length OC, which is now the hypotenuse of our right angle triangle. If I call this point M, it's the hypotenuse of triangle OCM. All I need to know now is maybe what's the measure of this angle right here. Well, the neat thing is I could draw another similar congruent triangle right here. The radius meets that point of tangency also at 90 degrees. This is also 20 millimeters. And this angle would be the same in both triangles. So 50 divided by 2, that angle is 25 degrees. All right. So from 25 degrees, I know the opposite side is 20. I'm looking for the adjacent side, OC. The trig ratio that uses opposite and adjacent is the sine ratio. So the sine of 25 degrees will equal opposite 20 millimeters over the hypotenuse side OC. So how do we find the length of OC? 20 millimeters divided by the sine of 25. So 20 divided by the sine of 25 gives us a length of 47.3. To the nearest millimeter is 47 millimeters. All right. Let's look at example 3. In many problems, the angle of elevation or depression is determined from the person's eye level and not from the ground. So let's read this question. In the diagram, the man on the ground is standing 12 feet from the wall. Well, let's label that. From here to there is 12 feet. The angle of elevation from his eye level to the eye level of his wife in the building is 62 degrees. So the angle of elevation, we're told, is 62 degrees. If the man's eye level is 6 feet above the ground, so the man's eye level from here to here is 6 feet, and his wife's eye level is 5.2 feet from the top of the building, so her eye level from here to there is 5.2 feet. Determine the height of the building, the nearest tenth of a foot. So we want this whole height. But again, our right angle triangle doesn't have that whole height. All right, our right angle triangle is right here. So there's our right angle triangle. We're going to look for this side, x. And if I can find x, then I can use that to figure out the height of the building. So from the angle we're given, 62 degrees, x is opposite. We know the adjacent side is 12. Trig ratio is opposite adjacent is our tangent ratio. So the tangent of 62 degrees is opposite x over adjacent 12. So I can solve for x by saying 12 times the tangent is 62. So 12 times the tangent is 62 is a measure of about 22.56. And I'll write 22.6, but we're going to keep that whole thing in our calculator, and we're not going to round till the very end of the question. So I now know x. Now I want to find the height of the building. So to solve for h, I want to add the man's eyes are 6 feet from the base of the building, so 6 feet. Add that to x, which is 22.6 feet. And add that to the lady's, the distance from the lady's eyes to the top of the building, which is 5.2 feet. So we add all those together, and we round it now to the nearest tenth of a foot, and we get our height to equal 33.8 feet. All right. Beautiful. Bearings. A bearing is an angle measured clockwise from the north direction. The boat is on a bearing of 40 degrees, often written as a three-figure notation, 040 degrees. So you start at north and you go clockwise. There's a 40-degree bearing, all right, or 040 degrees. So you've got a 150-degree bearing diagrammed. We've got a 225-degree bearing and a 330-degree bearing. They all start at north and head clockwise. Start at north and head clockwise for the indicated distance of degrees. So let's use the idea of bearings in this diagram in this question. A ship travels 6 kilometers from point P on a bearing of 120 degrees to position Q as shown. So at position Q, it then travels north until it reaches position R, which is due east of P. So I travel north up until position R, and it tells us that is due east of P. So there's our right angle triangle. East and north will meet at 90 degrees, east and south. All right. We're told the ship traveled 6 kilometers. And the question now says, how far east of P is the ship at position R? So we're looking for this distance right there from P to R. Well, I was told that the bearing was 120 degrees. So that's our 120 degree bearing. Well, we know that north and east meet at 90 degrees. So 120 subtract 90 means that this angle is 30 degrees. So if I know that angle in the triangle, and I know one side, the hypotenuse is 6, I can find the third side, x. So from 30 degrees, x is adjacent. We know the hypotenuse. The trig ratio that uses adjacent and hypotenuse is our cosine ratio. Cosine of 30 degrees equals adjacent x over hypotenuse 6. So I solve this equation for x. 6 times the cosine of 30, and I get 5.2 kilometers. So I'd answer the question, I would say, how far east of P is a ship at R? The ship is 5.2 kilometers east of P at R. Part B, the ship continues traveling north for a further 12 kilometers to position S. So we're going to keep going north for another 12 kilometers till I get to position S. Determine the bearing of S from P. So now I want to know this bearing from S to P. So they're looking for this bearing right there. How am I going to find that measure? All right. Well, to help me figure out that bearing, let's find angle theta, which is inside this triangle right here. So inside that triangle from theta, I know the opposite side is 12. I just found the adjacent side, which is x, 5.2. So I'm going to use my tangent ratio to find angle theta. All right. So tangent of theta would equal 12 over 5.2. I go ahead and I solve for angle theta then. Angle theta turns out to be 67 degrees. Second function tangent, 12 divided by 5.2. So if theta is 67, and I know that that's part of a right angle, I can figure out the bearing by going 90 minus 67. So my bearing would be 90 degrees minus 67 degrees, which is 23 degrees, or proper notation for bearing would be 0 to 3 degrees. All right. Part C, if the ship maintains an average speed of 9 kilometers per hour throughout the journey, determine to the nearest tenth of an hour the time taken for the journey. All right, let's go back to the diagram. We need to know how far it's traveled. So we need to know its total distance. So if I'm looking for total distance, I need to know what this distance right here is. Let's call it y. All right. So we know it went 6 kilometers from P to Q. We know it went 12 kilometers from R to S. We don't know how far it went from Q to R. So that's our distance y. So in the triangle PQR, I can solve for y. I know the hypotenuse is 6. I know the angle at P is 30 degrees. So from 30 degrees, y is opposite, 6 is hypotenuse. I'm going to use my sine ratio. So the sine of 30 degrees is opposite y over hypotenuse 6. So if I solve for y, 6 times the sine of 30 equals 3 kilometers. So now I know my total distance traveled. It went 6 kilometers from P to Q. It went 3 kilometers from Q to R. And it went 12 kilometers from R to S. So the total distance traveled is 21 kilometers. We were asked to find the time taken for the journey. So let's use our distance formula. The distance equals speed times time. We just found out that the distance is 21 kilometers. The speed is 9 kilometers per hour. Find the time. So our time will be 21 divided by 9. Or as a fraction, they're both divisible by 3, so that's 7/3. So that's 2 1/3 hours. And it says the nearest tenth of an hour, 2.3 hours. All right. Great. You've got your assignment sheet. Do the ones that you're supposed to do.